Today's topic is Border Gateway Protocol. Let's see how to configure BGP session between L3 devices, as well as let us discuss how BGP works to choose the best route to route the traffic. This is the topology we have taken for our BGP session establishment, and here this is one autonomous system, and these two routers belong to another autonomous system. So the configurations I made are shown here. The router 1 takes input of router BGP with an autonomous system number 100, and it advertises few routes as well as creates a neighbor router for BGP session establishment. You can check the neighbor sessions through IPBGP summary. It shows who are all neighbor to this BGP router. To know about the state details, show IPBGP neighbor command gives you the number of control packets details as well as the state mission details of the established BGP sessions. So here this three routers belong to autonomous system number 100, and whereas this two routers belongs to autonomous system number 900. You can see that the network of link between R1 and R3 advertised to router 2 with a flag B in the RIB of the router 2. It implies that this destined route has been learned through BGP protocol, and the administrative distance of 20 implies that the route is learned with help of IBGP. Further, we will discuss what is IGP and let it let me explain about you internal BGP as well as external BGP. So these are the BGP routes in our configured topology. Let me discuss few topics and the specialities of BGP. The various control messages involved in BGP are open, keep alive, update, and notification. An open message is the message sent between the peers to initiate the session. It carries BGP version, local autonomous system number, BGP router ID. For our configurations, we have to manually assign router ID and even AS number. These two information will be propagated with help of open messages. Keep alive message is sent periodically for every 60 seconds, which is a default time taken by the BGP session establishment, and a 180 seconds of hold time period. Hold time period is the period that takes the router to declare the pair BGP is dead. Update message are used to exchange routes between pairs, and notification message are sent where there is a fatal error conditions. It's a kind of update message by the BGP routers. If notification messages are sent, the BGP peer session is turned down, and few of the final state missions of BGP session are ideal, connect, active, open sent, open confirm, established. Let's see the significance of each state mission and the states of the state missions. The ideal state of the BGP is the initial BGP state. Connect is the state BGP waits for TCP connection with the remote peer. If it is successful, an open message is sent. If unsuccessful, the session is placed in an active state. And the BGP session state goes to active when BGP attempts to initiate a TCP connection with the remote pair. If successful, an open message is sent. If unsuccessful, a BGP will wait for a connect retrieval timer to expire. The state of the session goes to open sent when BGP has established the TCP connection and sent an open message. Once it receives and reply open message, the BGP peer will send a keep alive messages. Open confirm state of the BGP session confirms that BGP listens for the reply keep alive message of from each BGP peer. The established state of the BGP session declares that BGP peer session is fully established and update messages containing routing information will be sent. All the BGP sessions are established with a TCP port number 179. And BGP autonomous system number ranges from 12655535. With that, 64512265535 autonomous system or private autonomous system, which are reserved for internal use. So for our configuration, we have to use the ranges not lying in this range. We have to go for BGP when multiple connection exists to external AS. And we have to go for BGP when you have a gateway connected to external autonomous system through different providers, and if suppose same providers are used but different routing policy is required, then we will be going for BGP session over the autonomous system routers. The existing routing equipment can handle more number of traffic. The administrative distance of EBGP routes is 20, while the administrative distance for IBGP is 200. Generally, for routing inside autonomous system, we go for some other dynamic routing protocol. It is evident that the value of 200 implies that it is poor in routing over interior autonomous system. Let me see the two major features of BGP: route reflector as well as configurators. Before getting this, we can know about the terminologies of BGP. We call BGP speakers for BGP routers, as well as the neighbor BGP routers as its peers. BGP requires all IBGP peers to be fully meshed so that it can route efficiently. But we need to avoid that fully meshed because we can reduce the unnecessary traffic between the routers. There comes route reflectors. Route reflectors allows us to bypass this restriction. Let's see how to configure BGP reflectors in our topology. Rather than the routers in the IBGP keep on advertising their routes, a route reflector configuration would help the BGP router to act as a server and the rest of the BGP neighbors to act as a client. So your server client messaging would be accomplished, which reduces the unnecessary advertisement of the networks. Let's see how to configure BGP reflector. So we are making this router to act as a server to advertise routes to its connected pairs. So within this autonomous system, R1 will act as a server for updating the routes. So this results with fewer neighbor connection. Eventually will achieve a less bandwidth and CPU usage. So this is a way of reducing the bandwidth. Let's explain you confederation. Confederation is another way of alleviating the requirement that IBGP routers to be fully meshed. So as we see how we are reducing the bandwidth and avoiding the fully meshed topology in IBGP, we can use configuration as another methodology to reduce the traffic as well as avoid the requirement of having IBGP to be fully meshed. So assume that if router 1 belongs to autonomous system 777 and these two routers belongs to autonomous system 888 and this one belongs to autonomous system 500. So what happens here is it will be keep on propagating the routes with autonomous system number 777. I'll just bring it here to your notice. This is 777. This is 888. This is 500. This both belong to autonomous system with 300. So so you can see here that we have a you used a configuration autonomous system number 300. That here refers that we have grouped two autonomous system to a single autonomous system, and the outside autonomous system number 500 doesn't know the routes connected with the individual autonomous systems. The command neighbor of this autonomous system would be configured with autonomous number 300, so it doesn't know and not aware of the routes being uh, advertised by 888 autonomous system routers. Rather than it uh, possess that it is connected with a peer BGP neighbor with autonomous system number 300, which is configured here as confederation autonomous system. So with this, we will go with the various type of attributes that BGP possess. The various type of attributes BGP are well-known attributes and optional attributes, and it can be broadly classified as mandatory and optional. And well-known attributes are supported by all BGP routers, whereas optional attributes are supported by BGP routers on manually configured routers. So that word optional takes that it's not to be supported always by the BGP speaking routers. Well-known attributes or standard attributes supported by all BGP neighbors and BGP routers. Well-known discretionary the standard attributes supported by all BGP implementations. As I said, optional is not mandatory for all the BGP routers to get configured. Coming to various BGP attributes, we have nine attributes over here. Let we first get to know what are mandatory attributes and what are optional. The first three are mandatory attributes: AS path, next hop, and origin. That is always available at show BGP command. So you can see AS path, next hop, and local preference. So the best path determination of BGP depends on these attributes. If BGP contains multiple routes to same destination, it compares the routes in pairs, starting with the newest entries and working towards the oldest entries. To determine the best path, the order used to select the best path for routing traffic is weight, local preference, locally originated, AS path, origin code, MED, BGP route type, age, router ID, peer IP address. This is the order to decide which route is the best route for routing the traffic. The weight attributes are applied to inbound route, and dictated to outbound path. So the weight configured on the interfaces would be affecting the incoming traffic, affecting the sense like it will receive with the previous weight value while for the incoming traffic, and while going outside from the router it updates with the configured weight. That is called dictating through outbound path. So weight value can range from 0 to 65535. We can just see how to configure weight value. Weight is a proprietary Cisco attribute. Let's see how it's been configured in Cisco routers. We can configure weight value for specific routes from a particular neighbor. That's what I have configured here. So first we have created the access list. Here we call it as prefix list, so we just have a collection of prefixes to be permitted with help of a route map command. It's a filter command which takes input of what are the prefixes to be allowed for the updates with the configured weight. So here when the route advertised by the peer router with the network ID of between R4 and R5, which is 192.168 here, comes here, then it assigns weight 200 on updating on update packets. So that is the that's how weight attributes are used. The highest weight attribute is preferred for routing. So here we have configured this network as peer. The command the command neighbor with the weight. So obviously this link would be chosen for routing traffic to reach this network. This here is 192.168 network. Then later we go for local preference, which is a mandatory attribute applied at inbound and dictated outbound. And the range for local preferences are 429.4967.295. The highest preference would be taken for routing. Default is 100. The local preference value can be specified for all inbound external routes. This is the way for configuring local preference values. In the similar fashion, how we have configured local preference through route map, we can also create local preference through route map. That is a way of configuring local preference. Another way is this way. So we have configured a local preference for 200 for this router, and for this router we are going to give local preference value of 300. So obviously highest local preference will be chosen for your routing. So this link will be chosen for your routing. AS path is an attribute which applied at outbound and dictated through inbound. Generally shortest AS path would be taking the route. Generally we prepend the existing AS path results in longer AS path. For prepending, we can use access list way of configuring the prepending AS path. So we are prepending AS number 200 for routes. So actually I have configured wrongly. This is also correct. Yeah, we can configure it like this way, and you can check. But still, you didn't apply the route map for the advertised route. For that, by this way, we are configuring this route to take the route by assigning prepending AS path 200 to the route. So that we can check it over here. Show IP BGP. வேலை கிடைச்சிச்சு. நம்ம டைமகர் ஆயிட்டோம். ப்ராப்ளம் கண்டுபிடிச்சிட்டோம். ப்ராப்ளத்தை கண்டுபிடிச்சிட்டோம் மாப்ள. ப்ராப்ளத்தை கண்டுபிடிச்சிட்டோம். என்னோட தொழிலே இதானே. தொழிலே எப்படி எப்படி பிஜிபி ரூட் வர மாட்டேங்குது மாப்ள. என்ன பண்றது தெரியலடா. என்ன ஆச்சு எனக்கு தெரியலையா? வரமாட்டேங்குது சாமியா. ஐயா சாமியா வரமாட்டேங்குது. Nothing is coming. கோளாறு சட்ரா வர மாட்டேங்க. Why? I don't know மாப்ள. ரூட் சம்மரைசேஷன் அங்கேயும் எனேபிள் பண்ணிக்கோ. இங்கேயும் எனேபிள் பண்ணீங்கன்னா முடிஞ்சிச்சு அப்படின்னு நினச்சின்னு இருக்கிறேன். ஆனால் அது கிடையாது. ரூட் சம்மரைசேஷன் will happens only on the update message. The message from which you are getting would be not summarized. That's the command for the router 1. Are you getting? Let's try with giving no auto summary. Show IP BGP. So this is how we have to configure AS path attributes. Till now we have seen mandatory attributes. Let's see remaining things in next episode. Till then, bye.